Right. So we're going to continue from where we left off the last day, and I'm actually on. Now, again, I just want to confirm there was absolutely no issue at all with the homeworks. What about some of the later ones with the absolute values and things like that, and and those types of questions? Was there any problem with those? Let me see. Where's my chat thing? Stuck on the last one. What number was that, Kevin? Number 17. Perfect. Okay, I'll do number 17 now. Okay. Okay, so number 17, it says if 4 plus pj, so 4i plus pj, 4i plus pj is perpendicular to p plus 1i, minus 2j, find the value of p. Find p. Okay, so the very, very last thing I said to you in the last class was this. I said, if you have two vectors, u and v, okay, and if u is perpendicular to v, then AC plus BD equals 0. Okay, so you multiply the i's, you multiply the j's, add them, and if you get 0, they're perpendicular to each other. Okay, so we're going to use that now to find what p is. So in this case here, we have multiply the i's, so we have 4 times p plus 1, plus multiply the j's, p times minus 2 is equal to 0. Okay, so 4p plus 4 minus 2p equals 0. 2p plus 4 equals 0. So p is equal to minus 2. Okay. Now, you could just as easily have done this, okay? That p over 4, j over I is equal to, okay? Now, if you're looking at slopes in this case, the slope of this one is p over 4. The slope of the other one is minus 2 over p plus 1. Okay, that's the slope on the other one. Okay, the slope of a vector, slope is always j over I. Okay, your slope is always that. Now, if they're perpendicular, then you get the second one, turn it upside down, and change the sign. Can you remember that from your linear, from your lines? So if they're perpendicular, then one is the negative reciprocal of the other one. You turn it upside down and change the sign. Okay, that's another way to approach it. And you'll get exactly the same thing. Okay, so minus 2p equals 4. So p is minus 2. So either of those methods will work. Okay, give me a thumbs up when you're all happy with that and I can move on. missed that. Okay. Perfecto. Happy out, Kieran? Perfect. Excellent. Right. Onwards and upwards we go. So the next thing that we're going to do today is just a little bit of trig and how we use trig in vectors. Okay. So, right. Okay, so we're going to start with this idea of a triangle, a right angle triangle. Okay, and I'm going to call this thing here X. I'm going to call this Y, and I'm going to call this thing Z. And we're going to give this an angle here of theta. Okay, X, Y, Z, and theta. So if we look at just what sine and cos are. So sine of theta is Y over Z. That's the definition of sine. Sine is the opposite over the hypotenuse. Okay, that means from here that Y is Z sine theta. Okay, so the length from here to here is exactly the same as Z sine theta. Okay, and we have that the cos of theta is X over Z. So X is Z cos theta. Okay. And we're going to use this over and over and over and over again. Okay. Right. So let's have a look at these. Example 1.5. So here we have a triangle like this. Okay, they give us the hypotenuse as 10. They give us this angle as 60. Okay, and here is A, B, and C. And they ask us to find the length AB. So find the length AB and the length BC. Okay, so you can see here that it's the same. To find the length AB, it's like finding X, and to find the length BC, it's like finding Y. So the length AB is Z cos theta. Okay, the length AB is like X, so this is equal to 10 cos 60. Okay, and the length BC, which is like Y, Y is Z sine theta, which is 10 sine 60 degrees. Okay, now if you put them into your calculator, the cos of 60 is a half, so 10 halves is 5, so that's 5 centimeters. And sine of 60 is root 3 over 2. So this is 10 times root 3 over 2 is 5 root 3 centimeters. Okay. Now, in practically all of these, okay, we'll do the next one as well. Okay. Any problems with that? Everything fine? Okay, we're going to the next one. So, I'll leave that for a minute. everything's grand. I'll just clear all your statuses here maybe or something like that. Can I do that, I wonder? I can't. Okay, perfect. Right, we're going to the next one. So the next one says, right, 1.6. In the given triangle, find x, y, and y, z. Okay, so it's going to be the exact same problem here. This is exercise 1.6. Oh, you'd be so sick of this at the end of it, lads. This will become completely and utterly automatic. It doesn't look like 70 degrees, but we'll put it in there anyway. That's 70 degrees apparently, and this is 4 centimeters. Okay, now, in this case, I want you to see that y is opposite the angle, and x is beside the angle. Okay, so if you take it the same way, this one is going to be beside the angle, and that one is going to be opposite the angle, using the same notation as above. Okay, the y will always take the sine, and the x will always take the cos. And the way I like to think about it is this. Okay, here we have the hypotenuse of this triangle, and here is the angle. Now, we can find the two sides from here. This side is away. That's away from the angle. Okay, and this one is beside the angle. Okay, and I always think, you know, I pretend that I'm rich in a hotel and someone comes up to me and you just sign away everything. Just sign everything for your room. Sign away. Okay, sign away. So sine is always away from the angle. Okay, so this side here is going to be, if we just look at it that way, this side here is going to be 4 sine 70. So that's going to be this side here. Or we call it y there. Why did I change that? And x is 4 cos 70. Okay, and just pop those into the calculator, and you get this one is 3.76. That is the sine one is 3.76, and the beside one is 1.37. Okay, right. So sine away. That's how I always think about it. Sine away, cos beside. Now, I'm going to do one more very, very quickly here, and then I'm going to let you take them, try one yourselves. No, I won't. I'll do that. I'll do one more anyway. We'll see. Okay, worked example 1.7. Right. So here we have 1.7. It says, if the tan of a particular angle is 8/15, find sine A and cos A without using mathematical tables. Okay, so what you do here in this case is, and this again is kind of a junior cert type problem. Okay, this is you might kind of remember this from junior cert. Tan is always opposite over adjacent. Okay, so just draw the little bugger out. Okay, so what we're going to do is we're going to just say that here is an angle A. It's a right angle triangle. Okay, the opposite is 8 and the adjacent is 15. Okay, and we'll call this Z for the crack. Okay, now Z squared is 8 squared plus 15 squared is 64 plus 225 is 289. That's Z squared. So z is the square root of 289, which is 17. Okay. Then sine of a, remember this, it's silly old Harry caught a herring trawling off America. Okay, so sine of a is opposite over hypotenuse. That's 8 over 17. And the cos of a is adjacent over hypotenuse, which is 15 over 17. Okay. Now, so if you're given the tan of the angle, you can find the sine and the cos by using Pythagoras. Now, this particular angle, triangle here is what we call a Pythagorean, well, a Pythagorean triple. It gives rise to a Pythagorean triple. Okay, and Pythagorean triples are interesting from the point of view of they're all whole numbers. All the numbers are whole numbers. All the sides are whole numbers. Okay, so I'm just going to minimize this a little. Okay, everyone okay with that so far? Yeah, can I take this board away? Yep, perfect. Okay, excellent. Oh, that's a bad board. Oh, that's not even going to work. Let's have a look at what's in this one. Oh, that's worse. Oh, that's all going to come out. Okay. Right. That's about the closest I get to an exercise now in the week. Right. So, Pythagorean triples. The first one is this: 3, 4, and 5. Okay, 3, 4, 5 is a Pythagorean triple. 3 squared plus 4 squared is 5 squared. Now, all multiples of that are also Pythagorean triples. They're also Pythagorean triples. Okay, so now the reason I'm telling you this is because you'll see these numbers all the time. Okay, the next one is 5, 12, 13. The next one is 8, 15, 17. There's 20, 21, 29, I think. There's 40, 9, 41. And they're the main ones, okay? All multiples of those are also Pythagorean triples. And we'll just get to see them a lot. So you'll often see something like an angle of tan to the minus 1 of 4 over 3. Okay? Now, if I see an angle like that, I know that that's from a 3, 4, 5 triangle. I know that. Okay? And in fact, well, yeah, look, you'll just get to recognize those and see them everywhere. Okay. So they're all Pythagorean triples, and there's infinitely many of those, all kind of different ones, you know. Infinitely many of them, yeah. Okay, so we'll come back over here now. We'll do the next example. Okay, let me see now. Right, the next one it says here. Here's a triangle. Okay, this is 20. This angle here is theta, and they tell us that the tan of theta is 4 over 3, or that theta is tan to the minus 1 of 4 over 3. They're the same thing. Okay, they're exactly the same thing now, the two of those. Now, I know that this is a 3, 4, 5 triangle. Okay, and the way I want to think, you need to think about it is this. Always think tan of theta is sine over cos. Tan is sine over cos. That's always true. So what this means, in essence, is that the sine takes the 4 and the cos takes the 3. So from here, I can say that I know it's a 3, 4, 5. So the other side is 5. Sine theta is 4 over 5. And cos theta is 3 over 5. Okay. Just a nice trick. The more you do these, the easier this becomes. Okay, this will become second nature to you in a few weeks. It'll be absolutely second nature to you. Okay, tan is always sine over cos. So when you're looking at the tan of an angle, if it's a Pythagorean triple, you put the top number goes with the sine and the bottom number goes with the cos, and the third side is on the bottom then. Okay, so in this case it says find the length AB and the length BC. Okay, now this one is away, so the length BC is 20 sine theta, sine away, which is 20 times 4 over 5, which is 16 centimeters. And AB is the other one that's beside the angle, so that's 20 cos theta, which is 20 times 3/5, which is 12 centimeters. Okay, I'm just going to give you a second to take that down. I'll be back in literally 2 seconds. Okay, lads, right, we're back. We're back. So is everyone happy with that now? We've kind of come to terms with what we've just done. Are 3, 4, and 5 in every Pythagorean triple? No, absolutely not. Absolutely not. No, absolutely, that's a dirty lie. There's loads of Pythagorean triples, loads and loads of them. There's, as I said on the other one here, but when finding a side, like in this case here, I see what you're saying here now. Well, if you know that the triangle is a 3, 4, 5, if you know that's a 3, 4, 5, okay, and this is always the hypotenuse that's the longest side. Well, you can just, I mean, you can scale these up. Is that what you're asking me? Like this is a 3, 4, 5. So if that's multiplied by 4, this must be 16 and this must be 9, or the other way around. Is that what you're asking me, Kevin? Where the 20 went? Yeah, it didn't go anywhere. It's still there. This triangle. Okay. Okay. Right. What we have is when you have a triangle like this. Okay, I'm just gonna maybe draw this out. That's so what when you just right. Okay. So I'm going to say that here we have this triangle here. This one here has sides of 3, 4, and 5. Okay, they form a Pythagorean triple. This little small triangle here. Now, that there is the angle A. Okay, so we can see here that the sine of A is 3/5, and the cos of A is 4/5. Now, if I were to come out another 4 here, okay, if I were to come out another 4 here, then this triangle would be 8, this would be 10, and this would be 6, because again, these triangles are similar. This small triangle here is similar to the big triangle here. Okay, because they both have a right angle, they both have the angle A. This is 90 minus A, and that's 90 minus A. So they're the same, they're exactly similar, so their side lengths are in proportion. So if we look at the sine of A now from the bigger triangle here, which is the blue one, we'll say, if we look at the sine and cos and tan of the blue triangle, okay, then we'll say that the sine of A is 6/10, which is 3/5, and the cos of A is 8/10, which is 4/5. So you get the same thing. And all right-angled triangles that have this angle A will have the same proportions for their sides. So if this big one here now was actually 20 long, you would use the same proportions to get the other sides. So that would be twice as long as this. This must be twice as long as that. And this one down the bottom must be twice as long as that. So that would be a 12, 16, 20. So the 20 isn't gone anywhere. The 20 is still there. It's just that we have the lengths of the other two sides now as well. 20 hasn't gone anywhere. It's still there. Okay. Right. Now, There's exercise 1C there. And I want us to do this. This is where we're actually going to spend some time on this, okay? We're going to spend a small bit of time on this one because it is important that we're able to do a little bit of trig. I don't want to rush us with the trig at all. Trig is kind of tricky. So, right. Let's have, now I'm finding a side. 3, 4, 5 in every Pythagorean triple. No. Right, okay. I still don't know if I've answered your question, Kevin. Okay, grand. Right, we look at exercise 1C, and we look at it says write down the lengths of the missing sides in terms of h sine theta and or cos theta. Okay, so in the first one there, it's going to look like this. So here is h and here is theta. Okay, so this side here is, it takes sine, so it's h sine theta, and this one here is h cos theta. Okay, it's h sine theta, that's h cos theta. Right, the third one there would look like this. Here's 1 and 2. That should be a right angle here. That should be a right angle there. And this is theta here, and this is h. So that's the hypotenuse. Now you can see that this one is away from the angle. It's away. So that's h sine theta. And this one here is beside the angle. It's h cos theta. Okay. Right, and you can figure out the rest from there, okay? You should be grand from there. Now, we look, is that okay? So this is the hypotenuse, obviously, because it's opposite the right angle. Here is the angle theta. There it is. This side is opposite the angle, so that takes the sine. And this one is beside the angle, so that takes the cos. Okay, so whatever h is and whatever theta is, you can find the other two sides. Right. Okay. Question 2. All of the following parts should be done without finding the value of a. So if the tan of a is 5 over 12, tan a is 5 over 12. Okay. This means that we are dealing with a 5, 12, 13 triple. Okay. 5, 12, 13. So now I'll do it out again. I'll do it out the short way and the long way and the short way. Okay, so this is our triangle. This is our angle A. We put it there. Tan is the opposite over the adjacent. So that's 5 and that's 12. And when you do Pythagoras on this, you get that this side here is 13. So the sine of A is 5 over 13, and the cos of A is 12 over 13. Okay. Now, if it were me, were me, I would just do this. Tan of A is 5 over 12. This is sine over cos. Okay, so the sine takes the 5 and the cos takes the 12. So sine of A is 5 over 13. Cos of A is 12 over 13. Okay. Now, the next one, we look at the next one. Tan of A is 12 over 35. I actually don't know that one. 37, I don't know, we'll figure it out. Okay, so 12, 35, I reckon 12, 35, 37, but we'll check it out, we'll see. So in this case, we'll draw it out. So here is A, this is 12, and this is 35, opposite over adjacent. So this side here is Z. Z squared is 35 squared plus 12 squared, which is 9 and 1225 plus 144 is 1369. And the square root of 1369, would that be 37? Someone give me a base of that. Square root of 1339, 1369. You're all cut out now. None of you have a calculator in front of you, huh? Yeah. Of course I am. Of course I am. Right, so 37 is there. So we now know that this is sine over cos. So sine of A is 12 over 37, and cos of A is 35 over 37. Okay. Now, the next one's a bit of a bugger. The next one is thrown into upset and upset you entirely. It says that the cos of A is 3 over 4. Now, this is not a 3, 4, 5 triangle. It's not. Because cos is adjacent over hypotenuse. So here is adjacent and there is hypotenuse. So now that's my unknown side. So 16 is 9 plus z squared. Z squared is 7. So z is root 7. That means that the sine of A is root 7 over 4. Okay, so you have to be careful that it's tan when you know these two sides. Okay, you have to be very careful that it is a Pythagorean triple. It's a Pythagorean triple if they're the two small, if you've got the two smaller numbers and it's a tan, then it's a Pythagorean triple. If it's a cos, you have to be careful, or a sine, you have to be careful. Now the next one, it gives us the sine, but that is a Pythagorean triple because they've given us the right sides. You just get used to these. Honestly, lads, if you're looking a bit confused now, you're supposed to. You know, you're supposed to have a big furrowed brow, and you know. So it'll all make sense as we go along. Honestly, this is going to be fine. So it says the sine of A is 9 over 41. So we'll draw that out. Sine of A is the opposite over the hypotenuse. Okay, so this now is x. So 41 squared is x squared plus 9 squared. So this is 16 and 1 and 81, 681 maybe, is x squared plus 81. That means that 1600 is equal to x squared, so x is 40. Okay, so they tell us the sine of A. Now we can find the cos of A is 40 over 41. Now, in 99% of cases, they will give you the tan of A when they're asking you a question. Okay, they will do that generally. Okay, so I'm going to get you to do question 3 there for homework. And I'm going to look now at question 4, and I'm going to get you to do question 5. Okay, I'll do question 4, and I want you to do question 5. Your grand, Pat? Wished, Pat? We need some kind of a beep. Just put type of wire, yes, yeah. Just type a wire in. You know, at least I get a beep then. Why? What multiply or what answer? Multiply or what answer, dude? Oh Jesus, no. No, 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 no. No, 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 no. We like fractions. Oh, we like them. You know, they're nice. We like fractions and we like surds. Okay? No, we don't have to do that at all, dude. Now, okay, this is, yeah. Honestly now, Kevin, this is going to seem very, very, very straightforward in a couple of days or in a couple of weeks. You'll just be kind of going, oh yeah, I know this. I know this. We'll be doing this so much that you can't help but but get it. If you don't get it at the moment, if you're still a little bit dodgy, it's grand. That's what I'm saying to you. Don't worry about it. No, we have to. All right, okay, fine, okay. Just drop it. Okay. Question 4. Okay, question 4. Right. Write x in terms of h, theta, and phi. Yes. This is h, this is theta, and this down here is the angle phi. Okay, right. So it says write x in terms of h, theta, and phi. Okay. Now, what they want me to do here is this. Okay. I've got 2 bits of information about both of these triangles, but I'm going to try to mix them all together. So I'm going to take this side here, okay, and that side there, if I take that triangle completely away for the moment, if I take this one completely away, that side there is going to be h sine theta. Okay, so this side here is h sine theta. Okay, now I'm now going to take this triangle over here and I'm going to redraw it out like this. Here is x at the bottom. This is the angle phi, and this here is h sine theta. Okay, and now we can do this either of 2 ways. I think it's probably a little bit complicated to go straight into the answer. So what I'm going to do instead is I'm going to say that here is the angle, this is the adjacent, and that's the hypotenuse. So angle adjacent hypotenuse means that the cos of phi is adjacent over hypotenuse. And that means that x is h sine theta cos phi. H sine theta cos phi. Okay. And that's what they want. Now, I know it looks really weird. I know that. But that's what they want there, okay? X is h sine theta cos phi. Now, you can kind of see it from here as well. Okay. Here we have the hypotenuse. It's just h sine theta. So this would be sine phi, and this would be cos phi. So x is h sine theta cos phi. Okay. Right. Okay. Right. That means we've now done up to vectors in I and j. Okay, which is great. Okay, we're doing okay. This is a nice little leveling. By the way, when we finish this chapter, we're kind of just going to ignore vectors for a couple of weeks, to be honest. We're just going to ignore them completely, really, doing any of this rubbish. But then we'll come back to them with a vengeance after we're finished accelerated linear motion. Right. So your homework is this. Bugger. Homework is equal to, I want you to definitely do 1C question 3, 1A question 2 and 3, like B and C. There's 2 of those that I didn't do. And I want you to do question 5 also. Question 5. No, sorry, I'm a bit of an idiot. Not 1A, not 1A. 1C question 1. Question 1, sorry. Okay, so 1C question 1 part B and C, question 3 and question 5. Okay, and if you do them, I'll be a happy puppy. Okay, right. I think that's a great place to call it a day. We've just done nearly an hour. So, I will talk to ye later on. When's the next day I have you? Saturday again, is it? Any questions? Have I lost anyone so far? Is anyone kind of saying, you know, bugger this, like? Okay. Up. Okay. Right, okay. It's very boring at the moment. No, look, lads, this is vectors. Okay, it's very, very boring. There's and it's a lot of trig, and it looks a bit stupid. Honestly, you know, this is just the groundwork. This is me. This is me showing you what a bucket and shovel is like before we start building sandcastles. Is that right? Okay, right. I'll talk to you again on Saturday morning. So let's listen. Have a great week and do the homework, and I'll talk to you then. Oh, and I'll send you on the link. Okay, take care, lads. Do I have everyone's email? I have Liam's. I have Kevin's. Kieran, do I have your email? I do. Do I? Was that sent to me the last day? Yeah, perfect. All right, so I'll send that on to you. Okay. All right. Take care, lads. Bye bye. Bye bye bye.